Hi everyone, I'm Amanda from Year 11 and my today's video of physics is about static electricity, where I will demonstrate how we can detect charges in objects using an electroscope. To start off, we need to understand the nature of matter. All matter is made up of atoms that consist of three types of smaller particles: negatively charged electrons, positively charged protons, and neutral neutrons. Normally, the electrons and protons in an atom balance out, which is why most matter we come across is electrically neutral. But electrons are tiny and almost insignificant in mass, and rubbing or friction can give loosely bound electrons enough energy to leave their atoms and attach to others, migrating between different surfaces. If there is an imbalance between the negative and positive charges in an object, this will result in static electricity. These charges can build up on the surface of an object until they find a way to be released or discharged. Now, how can we tell if an object contains electrically charged atoms? In this video, I made my own detecting device called an electroscope to figure this out. For this experiment, you will need the following materials: a clear jar, a plastic lid to fit over the jar, paper clips, aluminum foil, styrofoam, and a balloon. Firstly, grab the plastic lid and using a marker, mark 2 holes around the center. Then, poke those 2 holes using something sharp. This is what we should get in the end. Set it aside for now and get 2 paper clips. Straighten the paper clip such that the ends are slightly hooked, like what's being done in the video. This is what it should look like. Make sure to do this to both paper clips. Next, thread a straightened paper clip through a hole in the plastic lid. To make sure it won't move around, I glued it in place using a glue gun. Now do this to the other side. After that, grab your aluminum foil and cut out 2 pieces just like what is shown. Then, poke a hole into one end of the aluminum foil strips to get these. Afterwards, proceed by hanging them under the hooked parts of the paper clips under the plastic lid. Lastly, grab the jar and place the lid with the paper clips and aluminum foil strips on top of the jar. With that, our electroscope is complete. Now we can test it out. Grab the styrofoam and rub it against the balloon. The friction causes their surfaces to gain opposite charges. This can be proved with the electroscope. Bring the styrofoam close to the paper clips on top of the plastic lid and observe what happens. When the styrofoam was brought near the paper clips, the foils moved away from each other. Here's a closer look of what happened. Now, try the same thing but with a balloon. When the balloon was brought near the paper clips, the foils also moved away from each other. Additionally, we can also bring both objects to the electroscope, putting one object on each side. It can be observed that the foils moved closer together instead of moving further apart. To explain what just happened, when the balloon and styrofoam were rubbed together, the friction caused their surfaces to gain opposite charges. The styrofoam picked up electrons from the balloon and became negatively charged, while the balloon lost electrons and became positively charged. This is called static electricity. As I moved the styrofoam close to the wire on the electroscope, it detected the negative charge. The foil on the wire on the electroscope had a neutral charge at the beginning of the experiment. When the styrofoam approached the electroscope, the negative charge of the styrofoam repelled the negatively charged electrons in the paperclip and the foil. This created an induced charge. When those electrons reached the ends of those two strips of foil, they became negatively charged and repelled each other. This is what caused the foil to move. When the styrofoam was moved away, the charge returned to neutral and the strips moved back to where they were at the beginning of the experiment. The same thing happened when the balloon was brought to the electroscope, except the foils became positively charged instead of negatively charged. Since both foils did become positive, they still repelled each other. However, when I brought both objects to the electroscope, I placed one object at each side. As a result, one foil gained a negative charge from the styrofoam and the other foil gained a positive charge from the balloon. Because of the different charges, the foil pieces attracted each other. Thus, we can conclude that the presence of a charged object near the paper clips created an induced charge on the foil, causing the foils to either repel or attract one another. The electroscope was able to successfully detect charges in an object and allowed us to determine whether or not the object contained electrically charged atoms. This concludes my Tete with Physics, where I demonstrated static electricity by making an electroscope at home. Thank you for watching.